Welcome to another video for pre-calculus. In this video, we are going to discuss about combining functions. So we are going to divide this into two parts. The first one is the algebra of functions, and the second part would be composition of functions. So there are four different operations when we talk about the algebra of function. The first one is adding functions. So if we have f and g as two functions, and x in the domain of both f and g, then the sum of f and g of x is f of x plus g of x. Similarly, that's true for the difference. So the difference of function f and g, so f minus g of x equals f of x minus g of x. Similarly, we can find the product of two functions. So the product of the function f times g of x equals f of x times g of x. And then that's true for the quotient when we divide two functions as well. But there's a restriction when we divide. So the denominator cannot be 0. If the denominator is 0, then it's undefined. So let's look at some examples. So first, let's go ahead and find the sum of these two functions. So we are given f of x equals x plus 2 and g of x equals x squared plus 5x plus 6. And we are asked to find f plus g of x and its domain. So f plus g of x equals f of x plus g of x. Now f of x is x plus 2 plus g of x is x squared plus 5x plus 6. Now if we combine the like terms and put them in order, so we have x squared, then x plus 5x is 6x, then we have 2 plus 6, which is 8. So this is our function f plus g of x. Now this is a polynomial function, so we clearly know that the domain of this function is the set of all real numbers. So negative infinity to infinity. Now let's look at the difference. So f minus g of x equals f of x minus g of x. Now we know that f of x is x plus 2. Now just be careful, we are subtracting. So minus, I'll put a parenthesis here. So x squared plus 5x plus 6. Now that becomes x plus 2 minus x squared minus 5x minus 6 when you distribute that negative. And then we get this equals, so x, so when we combine them and put them in order, so we have negative x squared. So x minus 5x is 4x. Then 2 minus 6 is negative 4 or minus 4. Now again, this is a polynomial function, so the domain is all real numbers. Now let's go ahead and find the product. So f times g of x is f of x times g of x. And then f of x is x plus 2 times g of x is x squared plus 5x plus 6. Now if we multiply, so x times x squared is x cubed, x times 5x is 5x squared, plus x times 6 is 6x. Then we multiply by 2, so we have plus 2x squared plus 10x plus 6. And then let's go ahead and simplify this and combine the like terms. So we have x cubed, then we have 5x squared plus 2x squared, which is 7x squared. And then we have 6x plus 10x, which is 16x. And then we have plus 6. So that means this, sorry, I made a mistake here. So when we multiply by 2, this must be 12. And then this must be 12. So again, this is a polynomial function. So the domain for this function is the set of real numbers. Now let's go ahead and find the quotient of those two functions. So f over g of x equals f of x plus g of x. and then f of x is x plus 2 divided by x squared plus 5x plus 6. So one important thing here when you're finding the domain of this function here, especially in this case or in any cases, so we have to find the domain before we simplify this function. We can simplify, we can factor, and probably we'll be able to cancel out things. So we can simplify this one, but we need to find the domain before we simplify this. And then you know how to find the domain of this one. We already discussed that in one of the previous videos. So domain of this rational function consists of all x values such that the denominator is not 0. So that means we'll go ahead and solve x squared plus 5x plus 6 equals 0. And whatever number or whatever solution for that equation will exclude them from the domain of this function. So we can just factor this quadratic expression here. So this is x plus 3 times x plus 2 equals 0. So this means x equals -3 and x equals -2. So -3 and -2 are not in the domain of this function. So let's go ahead and write the domain. So domain is -infinity to -3 union -3 to -2 union -2 to infinity. Okay, so that's the domain of this function. Now we can go ahead and simplify this. So we can write x plus 2 over, so the denominator is x plus 3 times x plus 2. And then we can cancel out x plus 2, and then we get the function 1 over x plus 3. So this is the function right here, okay? But the domain is this one. So always make sure that we first find the domain before we simplify this. Now that was sum and difference. So let's go ahead and evaluate the sum difference or sum and quotient at a given value. So this is exactly same as what we did in the first four examples. In those cases, we had x here, but now we have a number. So it's exactly same thing that we are going to here that we did for the previous example. Okay, so this is going to be equal to f of -2 plus g of -2. Now we already know how to evaluate those functions. So we can go ahead and evaluate what is f of -2. So you just plug it in here. So we get -2 plus 2 plus g of -2, we'll plug it here. So -2 squared plus 5 times -2 plus 6. Now this is 0 plus, this is -2 squared is 4 minus 10 plus 6, and that gives us 0. Similarly, this one, we can do the same thing. This equals f of 2 divided by g of 2. F of 2 means we plug that in there in the function f, so that we get 2 plus 2 divided by g of 2 is 2 squared plus 5 times 2 plus 6. And that gives us 2 plus 2 is 4, 2 squared is 4 plus 10 plus 6. And then that gives us, so 4 over, this is 20. And then we can reduce that fraction to get 1/5. So the other way of combining functions, so that was the algebra, addition, subtraction, multiplication, and division. Now another way of combining function is called composition of function, or when we combine two functions in a way, then we get a composite function. This is very important tool when we move on to calculus and higher level math. This is used often, and the concept is very important. Okay, so we really need to understand what does this mean. And a lot of time I see students getting confused with finding composite function or knowing the meaning of the composition of functions. Okay, so let me tell you this one. So when we say function, remember when we first define function, when we say function, function is just like a machine. So we name that machine with some letter F or G or H. So that's the function. So usually what we do is we put something here, which is called input, or usually that is X, and then there's a function. So mathematically it's an expression, okay? So we'll put some numbers into that expression. We do math, we do computation, and then that will give us an output. So similarly, it's like a machine. So we put something here in the machine will process it, and then it gives us some output here, which is f of x. Okay, so f is the machine, x is the input. We put it in, we do some operation, and we get the output, which is called f of x. Now, when we talk about the composition or the composite function, we have two different functions. So just like this one, we have f, a function f, and then we have another function g. Okay, so what we are doing here is when we are finding composite function, we are sending that x or input through one of the function, and then we get the output. So immediately we send that output through the other function and we get another output. So for example, let's say this is g here, this box is the function g, and then we have another function, let's say f, and this box is f. So we have an input, we send it through here, let's say x. Now this g will operate that x, okay? So that machine will operate that x, and it gives us some output here. And we know that if we send x through g, the output is g of x. Now immediately we'll send this output through another machine or through another function, which is f, okay? And then we get output here. So when you send something through f, you get f of whatever you send through here as the output. So here we are not sending x through f, we are sending g of x through f. So that means the output is f of g of x. Okay, now this function here is called the composite function or composition of f and g. We can switch this and we can find another composition, and those two compositions are not same, but the process is same. Okay, that's how we find the composition. So these can also be written as, there's another notation for this one. So this can also be written as f, and there's an operator, composition operator. Okay, so composition of f and g of x. So these two are equivalent expression. So usually we call this g of x as the inside function and f as the outside function, or inner function and outer function. Okay, now to find the domain, when you're finding the domain of this composition function, we have to look at the domain of both f and g. Okay, so we have to look at the domain, especially the domain of the inside function. We'll see the restriction in the domain of the inside function, and then we'll see the domain of the composition, the composition function. Okay, why the domain of inside function is important is, in order to get through this composition, first we are sending this number or the input x through the first function, the inside function g. So if we cannot send something through g, then we are not going to get this output right here. Okay, so it's very important that we look at the domain of the inside function, and we use that restriction when we write the domain of the composite function. Okay, so let's look at some examples. So first one is we are asked to find the composition of f and g, and then the domain. Okay, so we have f of x equals x squared plus 2x plus 4, and g of x equals negative 3x plus 2. So I usually like to write this in the other notation. So we have the composition of f and g, so I'll write f of g of x. So always the second function here is the inside function. Now what I do next is I'll write f of, now I have an expression for g of x, it's given here. So I'll just bring the whole thing because it's g of x. So what is g of x? G of x is just negative 3x plus 2. So I'll bring it here and substitute for g of x. So negative 3x plus 2. Now all we need to do next is we are going to evaluate f of this quantity here, and we already have done this. Okay, we know how to evaluate a function. So whenever you are evaluating a function, you take this whole quantity and you are going to replace this x with that quantity in f, because this is f of a quantity. So you are going to replace this x with this quantity. Okay, so that becomes, this equals, so x is squared, but now x is negative 3x plus 2. So negative 3x plus 2 squared plus 2 times x, but now x is negative 3x plus 2 plus 4. Now all we need to do is we have to simplify this. So if you go ahead and simplify this, you're going to get 9x squared minus 12x plus 4. So that is negative 3x plus 2 squared. So if you do negative 3x plus 2 times negative 3x plus 2, that's what you are going to get. And if I distribute that 2, then I get negative 6x plus 4. Again, there's another plus 4. So 2 times this one is negative 6x, 2 times 2 is 4, and then we have another 4. Now if we combine the like terms, then we get 9x squared. So negative 12x minus 6x is minus 18x. Then 4 plus 4 plus 4 is plus 12. Now the domain of this composition function, this is a polynomial function, so the domain is all real numbers. Let's go ahead and find this composition right here. We are going to do exactly the same thing that we did for the first question. So this equals g of f of x. Now the inside function is f of x. So what I'm going to do is I'm going to go ahead and bring that f of x and put it here. So f of x is this expression right here. So x squared plus 2x plus 4. Now what I'm going to do is I'm going to evaluate function g at this value. That means in g of x, I'm going to substitute x with whatever this is. So wherever I see x, I'm going to plug this in there, okay? So that means it is negative 3x, but now x is this whole expression, x squared plus 2x plus 4, then plus 2 outside, this 2 right here. Now, if we distribute that negative 3, then we get negative 3x squared minus 6x minus 12 plus 2. And then when we simplify or when we combine the like terms, we get negative 3x squared minus 6x minus 10. And that is the composite function for g and f. And the domain again, so these are real numbers, so the domain is negative infinity. I mean, this is a polynomial function. There's no restriction in domain of f of x. There's no restriction in domain of g of x. So the domain is just all real numbers, okay? Now let's go ahead and evaluate the composite function at a given value. So again, we are going to do exactly the same thing. So we are going to rewrite this as f of g of 2. Now, if you look inside here, this one right here, this is g of 2. That means we have to find the value of g at 2. Okay, so what we need to find is we need to find g of 2. And we can easily do that. We can just substitute 2 here for x. Okay, so negative 3 times 2 plus 2, and that gives us negative 4. That means g of 2 is negative 4. So what we are going to do is we are going to substitute g of 2 with negative 4. Now this clearly says that we are evaluating f at negative 4. So we are going to take this one and plug it in here and here in this expression. So negative 4 squared plus 2 times negative 4 plus 4. So negative 4 squared is 16 minus 8 plus 4, and that gives us 12. Okay, now for this one to find g of f of 2, okay, so this equals g of f of 2, which means we need to find f of 2 first. So let's go ahead and find f of 2. F of 2 means we'll take 2 and plug it in here in place of x. So 2 squared plus 2 times 2 plus 4, which is 4 plus 4 plus 4, which is 12. So f of 2 is 12. That means this equals g of, now f of 2 is 12. Now what we need to do is we need to find g of 12. So we'll take this one and plug it in here. So negative 3 times 12 plus 2. Negative 3 times 12 is negative 36 plus 2. And that gives us negative 34. Let's look at one more example. Let's go ahead and find the composition here, and then we need to find the domain. So again, we are going to, so when you are finding domain, this one is a rational function. So let's go ahead and write this one first, and I'll tell you how to find the domain. Okay, so f of g of x. So we'll do the same thing, f of, so one thing when you're finding domain, first thing is look at the domain of the inside function. So the inside function is g of x. Now we really need to look at this one. What is the domain of this function? Or what's the restriction for the domain of that function? So we clearly see that we have 6 over x. That means x cannot be 0. So we really need to consider this. Okay, so x cannot be 0 for g of x. Okay, for the inside function, we have to look at the domain. Now let's go ahead and evaluate this. So g of x is 6 over x equals, now what I'm going to do is I'm going to take this 6 over x and put it in f. So right here. Okay, now that equals 1 over, now we replace x with 6 over x minus 3. Now, one thing you can just find, if you want, you can find the domain from right here, or we can simplify and find the domain. Okay, so if you want to find the domain from right here, what we cannot have is we cannot have 0 in the denominator. 0 in the denominator means 6 over x cannot be 3, because if this is 3, then we have 3 minus 3 equals 0. When it says 6 over x cannot be 3, means 6, when does 6 over x becomes 3? Whenever x is 2. So if I have x equals 2, then I have 6 over 2, which is 3 minus 3 is 0. That means basically from here, we can say that, okay, let me rewrite this. So it is 1 over 6 over x minus 3. So from here, we can say x cannot be 2. Or we can also calculate that at the end after simplifying this. So how do we simplify this function? Because we have a compound fraction here. We have 1 here, then we have 6 over x minus 3. So at least we can get rid of this fraction 6 over x if we multiply both numerator here by x and then this denominator by x. So if we do that, then we get x times 1 is x over, so when I multiply here, I multiply x times 6 over x, which is a 6, minus x times 3, which is 3x. I think that's all we can do. Now, if you haven't found the domain from right here, okay, if you haven't found the domain from right here, then we can also look at this one and find the domain. So here clearly we can say that 6 minus 3x cannot be 0. So if what makes this 0? And then if you solve for x, you get x equals 2. That means 2 is not in the domain of this function. So now when you write the domain, so we have to consider this one, the domain of the inside function and the domain of the composition. That means x cannot be 0 because for this composition, first x has to go through g and 0 cannot go through z. So that means 0 is not in the domain. And for the final here in this composition, x cannot be 2 because it gives us this whole expression as x over 0. Okay, so that means the domain of this function is in the set builder form. We can write x as that x is not equal to 0 and x is not equal to 2 and x is in the real number. Or we can also write that in the interval notation as negative infinity to 0, union 0 to 2, union 2 to infinity. Okay, now let's go ahead and find the composition of g and f. Okay, so this can be written as g of f of x. Now here, when we are finding the domain, the inside function here is f. So we have to look at what's the restriction for the domain for the function f of x. Now if we look at f of x is 1 over x minus 3. That means x cannot be 3 for f of x. If x is 3, then we get 1 over 0. So first restriction is x cannot be 3. So we really need to consider this. And then let's go ahead and find the composition. So g of, now f of x is 1 over x minus 3. Now what we are going to do is we are going to take this one, okay, and we plug it into g. So we are going to evaluate g at 1 over x minus 3. So what we do is wherever we have x in g, we are going to replace that x with 1 over x minus 3. So this is the only x that we have in g of x. So we can write that as 6 over, now in place of x, we write 1 over x minus 3. And then we can simplify this expression again by multiplying everything by, or numerator and denominator, both by x minus 3. If we do that, we get 6x minus 18, and here it cancels out, so over 1, which is just nothing in the denominator. Okay, so we get 6x minus 18. So there's no any restriction for the domain of this one because it does not have a denominator. So for this one, the domain is all real number, but we still have this restriction here, which we need to take in consideration. So the domain for this function is x, such that x is not equal to 3 and x is in the real number state. Or we can also write negative infinity to 3 union 3 to infinity, which is in the interval notation here. That's all for this video. I'll see you again in the next video.